Okay, on to 9.5 of Honors Algebra 2, adding, subtracting rational expressions. Deal with this in two parts again. How do you find the least common multiple, and how do you add and subtract rational expressions? So the first part here, we're going to be dealing with the least common multiple. Now, when you're dealing with just integers, I might ask what the least common multiple of 2 and 11 is. You need to think, okay, counting by 2s, counting by 11s, what's the first number that they both have in common? So if you start listing these, if you're counting by 2s, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. Now what's going to be the first number in the 11s, counting by 11s, that's on this list? That one's kind of easy. 22 shows up right away. Well, that's what we're going to do for rational expressions. Have my rag over there. Right. So rational expressions gets a little more complicated because the expressions, it's not a single integer. 4x squared minus 36. 6x squared plus 36x plus 54. Now, I've been saying a lot of this chapter, better you can factor, easier this is going to be. That's the first step. You need to break this down as much as possible. So if I'm looking at this expression, 4x squared minus 36, I'm going to take out a greatest common factor. And x squared minus 9 gives me x plus 3, x minus 3. You also need to deal with that 4. That 4 needs to be broken down as much as possible as well. And here I'll break it up. Just think of prime numbers. You need to get it down so you have prime numbers. 2 times 2. That's how we break down our 4. Going over here to the 6x squared plus 36x plus 54, I'm going to take out a 6. Okay, and now factoring x squared plus 6x plus 9 gives me x plus 3, x plus 3. And again, the 6. You need to think about how can I break up the 6. The 4 was 2 and 2. 2 times 2 is 4. 6, 2 and 3. Now, when we're figuring out what our least common multiple is, now that we have it broken down, we can see what pieces we need. Every piece needs to be represented. So what I like to do is just go right across the line and just write down what we have, what we need. Here we have a 2. So that 2, it represents the 2 in this expression. It also represents that 2 as well. So that's taken care of. So I'm just going to put off check marks of what I have. We have another 2, so it's going to be 2 times 2. That 2 is taken care of. We already have that 2 over there, so we don't need to check it off again. We have that x plus 3. Now, does that take care of that? It also takes care of one of those x plus 3s. We have an x minus 3. Checking that off. Coming over here now, we have that 3. So that 3 is taken care of. And we have one more x plus 3. I know we already have one down here, but there's another one over there that needs to be represented. X plus 3. So there's what we have. Now you just need to clean it up a little bit. You have 2 times 2 times 3. That will give us 12. 2 times 2 times 3. And then also we have x plus 3 and x plus 3. Since we have 2 of them, I want you to clean that up a little bit and have it as x plus 3 squared. And then we have x minus 3. Okay, we don't need to multiply the binomials anymore. I'd like you to leave that as your least common multiple. Okay? So going down the line, you're factoring and just seeing what pieces you need and what pieces need to be represented. Okay? Every piece only needs to be represented once. So when that 2 came down first, that 2 and that 2, and the other expression was also represented. Okay? So take your time and think about what pieces you need in that expression. Another example, 3x squared minus 9x minus 30 and 6x plus 30. Okay, so I'm going to go through the factoring quickly. Okay, so it took out greatest common factor of 3 and the factors of negative 10 that add up to negative 3 are negative 5 and positive 2. Over here now, take out that 6. Okay. X plus 5 can't do anything else with but 6. Right now it's 2 times 3. Okay, so now if I'm going to write this out, I'm going to start left-hand side, just work my way across. 3, so that means this 3 and that 3 is represented. We have our x minus 5. We have our x plus 2. We have another 2, or that is our first 2, sorry. And then x plus 5. Okay. So now again, clean it up a little bit. We have 2 and 3, so we multiply those together to get 6. X minus 5, x plus 2, x plus 5. Again, it's x minus 5, x plus 5. Don't need to rewrite those as, they're not the same, so you can't rewrite them. That's one mistake. People see the 5s, they want to go ahead and rewrite them as x plus 5 squared. They're not the same, so take your time and think about that. All right? Let's do one more example. Okay, so we have 5x squared plus 15x plus 10 and 2x squared minus 8. Factor in quickly. Over here we have 2. Okay, so that was quick factoring. You need to be able to factor quickly if you want to stop it and take a look at that again. You can see what I did. Okay. Now I'm going to go through the pieces we have, pieces we need. We have the 5. We have x plus 2, which this x plus 2 is also going to be represented. X plus 1. We have our 2. And we have our x minus 2. Okay. So everything's now represented. If I'm going to clean that up, 10. X plus 2, x plus 1, x minus 2. Okay, every piece is represented. It's nice and cleaned up. Can't put any of the binomials here, or at least you don't need to. If you want to multiply 3, you can, but you don't have to. That's it for part 1.